Hey class, today we're going to continue on with acids and bases, and we're going to talk about how the acid strength is related to the conjugate base's strength and how a base's strength can be related to a conjugate acid strength. So some acids are better proton donors than others, and we had a list where we had 7 strong acids and then we talked about weak acids. Same thing with bases. There are better bases that are better at accepting protons than others. So we have strong bases versus weak bases. One thing to note is the more easily a substance gives up a proton, the less easily its conjugate base is able to accept it, and vice versa. So typically, if you have a very strong acid, the weaker the conjugate base is going to be. The stronger the base, the weaker the conjugate acids. They're kind of like opposites of each other. So there are kind of 3 categories that we're going to kind of talk about. The first is typically if you have something that is a strong acid that completely transfers its protons to water, it's going to leave nothing undissociated within that solution. And so we say that it is a negligible base. Negligible just means it's so tiny, it barely even acts as a base. A weak acid, on the other hand, partially dissociates, so therefore it kind of results in a weak conjugate base. And then something that is negligible acidity or barely acidic at all will usually have a strong base as its opposite. So this chart is going to be given to you on your homework. But one thing I want you to know about this chart is don't become overly reliant on it. You should recognize if I give you an acid and say that it is strong, you should be able to tell me that it is negligible base. The way this chart works is over here on the left, we have acids and increasing acids as we go up. So my strong acids are on the top. I have weak acids in the middle, and then negligible acidity on the bottom. Up here, bases are going to go the opposite way. So typically, if I was going to give a conjugate base to a strong acid, it's going to be a negligible base. The conjugate base to a weak acid is going to be a weak base, and then a conjugate base to a negligible acid is going to be a strong base. If I do these following questions, the first one we're going to work through is label the following acids as either strong, weak, or negligible. So this problem tells you that all of these are acids. So we're going to find H2PO4 negative on the acid side. H2PO4 negative, and it says that it is weak. Oops. So we know that this is weak. Now, second part of the question is we're going to write the conjugate base. Knowing that these are acids means that they're going to donate protons. So here I'm going to get rid of a proton, or I'm going to donate a proton. That means it's getting rid of it. So HPO4, since I got rid of a positive charge, this is going to become -2. Then I'm going to see what this would be for my base. If you look at it, for my base, HPO4 -2, I'm going to see that that is a weak base. So then for the conjugate base, say if it's strong, weak, or negligible, which we said was weak. We're going to try it for these other 3. If you want to pause the video and try it yourself, you're more than welcome. I'm going to go through all 3 of these and say if these acids are strong or weak. So first off, HF. HF, we're going to see right here, it is a weak acid. Then we're going to look for H2SO4. We're going to see that H2SO4 is a strong acid. And then we're going to look for NH4 with a positive charge. And we're going to find NH4 with a positive charge right here under the weak acids. Oops. From there, we're going to write the conjugate base. So again, remember, acids donate, so we're going to lose a positive charge. So we lose a hydrogen and my charge becomes more negative. So I get F minus 1. Here I have H2SO4. I'm going to lose a hydrogen. Messed up. HSO4. I become more negative, so minus 1. And then NH4 plus, we become NH. I'm going to lose a hydrogen, NH3. Plus 1 minus 1 gives me no charge here. Once I get my conjugate bases, let's check to see if these are strong or weak or negligible. And if we remember our rules, weak acid should be a weak base. Let's go ahead and check that. We have an F minus. Again, it's in my weak base section. Here we have HSO4 negative 1. So this originally was a strong acid, which if we know the rules, we should guess that this is a negligible base. So let's find HSO4 negative 1. Here, HSO4 negative 1, it's going to be in the negligible base category. Okay. And then here we have a weak acid, which means NH3 should be a weak base. And if we look, NH3 is a weak base. Again, notice there is a correlation happening here. What if I did the opposite? What if I had you guys label the following bases as either strong, weak, or negligible, write the conjugate acid, and then we're going to label those conjugate acids as strong, weak, or negligible. So remember, all of these are bases here, so let's just go through and see if they're strong, weak, or negligible. We're going to start with Cl negative 1. Note that if we're doing this, we need to look on the base side since we said these were all bases. So Cl negative 1 is going to be a negligible base. Oops. PO4 minus 3. We're going to find PO4 minus 3 right here. Notice here it's weak. Why do I keep going the wrong way? Weak. Next, we're going to find HCO3 negative 1. HCO3 negative 1, it's in the weak section. And then CH3 negative 1, we're going to find down here, CH3 negative 1, it's in the strong base section. From there, we're going to write our conjugate acid. Now, since these were all bases, we have to remember, based on our last lesson, that bases accept a proton or accept a hydrogen. So the chlorine here would get a hydrogen and get HCl. It's gaining a positive charge, so negative 1 plus 1 gives me a 0 balanced. PO43 negative, we should recognize that PO43 negative is going to gain a hydrogen, so HPO4. I'm getting more positive, so this is just a negative 2 instead of a negative 3. Here, we're going to gain a hydrogen, so now I have 2 hydrogens, CO3. My charge becomes more positive, so it balances out to be neutral. And then the last one, we have CH4, because I'm gaining a hydrogen. Negative 1 plus 1 gives me no charge on this one. Now I have to see if these conjugate acids are strong, weak, or negligible. You can use your chart, but don't get too reliant on it because I'm going to expect you to be able to look at this and tell from your homework. We should see negligible and know that the opposite is going to be strong. If we double check that on our chart, HCl is in fact a strong acid. Here, if I have weak, I should have weak over here. And if you check HPO4 negative 2, HPO4 negative 2 right here shows that it is in fact weak. Next, if we have weak, again, we should have a weak conjugate acid, H2CO3. H2CO3 is in fact weak. And the last one, if I have strong, that means that this one is going to be negligible, or extremely small, it doesn't matter. And if we check CH4, it is in fact in the negligible category. That is the end of today's lesson. If you have any questions, please make sure that you ask. And otherwise I hope you guys have a great day.